Hello and welcome to an Edexcel Pearson GCSE Computer Science past paper question. This is the summer of 2022. This is paper 2, Application of Computational Thinking. I'll link in the description to paper 1. This is the practical paper. Now, this is the new specification. So the big change here is that it is just Python based. So there's no other languages anymore other than Python. That was a big change to the specification for GCSE based on compared with the old specification. So total marks for this out of 75, and we'll jump in and have a look at it now. Now you do need some files to go with this. This is linked down in the description to my Dropbox account. You'll find a link to all the files you need. Before we go into the paper, please do me a favor, like this video, subscribe to my channel. I really appreciate it. It encourages me to make more videos. My name is Mark Harrison and welcome. So we'll get started with question 1. In addition to this paper, you also have the programming language subset. Now, this comes with the exam paper and along with the exam files that you need. And it's going to be an incredibly useful resource to you in your exam. It specifies which parts of Python 3 are required in order that the assessments can be undertaken with confidence. Students familiar with everything in this document will be able to access all parts of the paper 2 assessment. So this is going to be really useful to you in your exam, and I've linked this down in the description for you to have a look at. You'll get this as part of your exam. So it's worth taking a moment in the exam, if you need to have a look at this, because you've got different parts of Python that could be useful to you in your exam paper. Question 1, suggested time 15 minutes. Now, the total time for this paper is 2 hours. So to take 15 minutes for this question 1, which is worth 10 marks, sounds about right. It's about the appropriate amount of time that you need to take on that. That is quite useful that Edexcel have put that there, because that isn't on the IGCSE, which is a 3-hour paper for paper 2. That's quite useful, so we'll go and have a look at that. A program is required to convert numbers entered by the user to their alphabetical equivalent. Only numbers from 5 to 30 are valid. Adding 60 to the number and then applying the function CHR generates the equivalent ASCII code for an uppercase letter. The table shows accurate test data for a functional program. So here we've got your test data for invalid input. 5 is equal to A, 22 is equal to R, etc. And then we've got invalid input there for 31. Open Q01.py, amend the code to create an integer variable named num and set it to 0. Take the input from the user and convert it to an integer. Check that the inputted number is between 5 and 30. Add 60 to the variable num and assign the result to a variable decimal code. Join strings together with concatenation. Display an error message. So each of those points are things that you need to do in your code. So we'll go and get started now with the first point. Create an integer variable named num and set it to 0. So here we can see comments. Add a line to create an integer variable num and set it to 0. So here we need to add our code, and it's num equals 0. As simple as that, and that's the first bullet point done. We've assigned the value 0 to the variable num. Bullet point 2, take the input from the user and convert it to an integer. So here we can see some more comments in our main program and things that we need to do. So num equals int input there, and we need to get the user to enter a number. So that will convert that into an integer. So that's the second bullet point done. The third bullet point, check that the inputted number is between 5 and 30. So here we need to do the code. So we can see that if there is between 5 and 30. So we need an if statement there. So if num is greater than or equal to 5, and just make that a bit smaller. So we need to check if it's between 5 and 30. So we'll put an and in there. And again, we'll tidy this up. Just make it look a bit better. Put a space in there, that's better. Num So we could say less than or equal to 30, or we could say less than 31, put less than 31. And again, tidy this up. So with those two ones there, we can either say greater than 4, less than 31, or we can say greater than or equal to 5 and less than or equal to 30. So that's the second point. Third point done, sorry. Add 60 to the variable num and assign the variable result to the variable decimal code. So complete the line to add 60 to num and assign the result to the variable decimal code. Decimal code equals 60 plus num. That's that done. And now the fifth bullet point, join strings together with concatenation. So we can see what we need to do here. Complete the line to join strings together with concatenation. That means to chain them together, to join them together. So print string. Now, I don't really like these spaces here. I do get rid of them. I think it's just a little bit tidier. And again, tidy it up, is equal to, and concatenation means I need to join them together, so I need to put the plus symbol in there as well, and CHR decimal code. Now, I think I will, because it's got all those spaces in there, I'll keep that in there. It won't make a difference to the running of the code, it just makes it more consistent. So that's that line of code done. Display an error message, so that is in the else here. So just simply print invalid input. Now, you need to save it as Q01 finished.py, and we will run it just to check that it's working. Now I'm going to save them in my folder here. So caps lock on here, and we will save it as Q01 finished. So do make sure you save it properly, save, and then we will run it. Always run your code to check that it's working. So we'll enter a number, we'll test all conditions. So we'll try out 4. That should be invalid input. I'm expecting that works. So run it again, run module. By the way, I'm using idle, which is I'm sure is what you'll be using in your exam. It's probably the most common way IDE to use Python. So now we'll try 5 is equal to A. So we're testing the extreme values of the ranges. We'll run it again. So we'll try 30. Yeah, so I'm happy with that. And that works. And that completes question 1 for a total of 10 marks. Question 2, suggested time 15 minutes. Again, this is really useful of Edexcel to do this. Don't get this with every exam board. You certainly don't get this in the GCSE, which I've also got videos on. So question 2, a program uses Turtle graphics to draw a simple image. This is the image that must be produced. So we can see the image there, it's like a circle. Both the circle and the outside square are centered on the horizontal and vertical grid lines. The outside square is 400 by 400, the circle is 200 across. The circle outline is colored gold. All other outlines, or other lines, are black. The program has errors and does not work correctly. Open Q02. So here is Q02, and again, it's linked down in the description to my Dropbox account where you'll find these files that you need. Amend the code to add a comment to identify the type of argument to the turtle.mode subprogram called on original line 19. So you need to go to line 19 and have a look at that. So there should be something here that we need to do. So add a comment to identify the data type of the argument to turtle.mode. So turtle.mode is standard, and we can see that in quotation marks. So we need to put hash symbol and put this is a string, and that's a mark for that. Fix the name error on original line 23. So again, look at the line numbers below, line 23. What is the name error there? Well, we can see screen.setup. Can't see a problem with that. That looks okay. That's not named incorrectly, but we can see width and height there. Now this is where you need to look very, very carefully, because we can see height, it's got an E in there, and here it hasn't. So that is what's missing. So we need to add that to fix that problem. So just minimize that and scroll down and look at the rest of the questions that we've got. Fix the attribute error on original line 28. So now we go down, 27, 28 there. Fix the attribute error on original line 28. The turtle equals turtle.turtle. So on this line here, so if we look at this, we'll see that .turtle attribute error there is wrong. To create a new turtle object, we need to have a capital letter in there. .turtle, that needs to be capital T. The fourth bullet point, fix the type error on line 36. So we go down to line 36 here. The turtle.pen down 200. Fix the type error here. And there should not be a number in there. If you look at pen up, that doesn't have a number in there. That shouldn't have a number in there either. So to fix that, we remove the number. By the way, we should really save this as we go, but we'll save it when we've been through everything. So fix the logic error that causes the vertical axis to be too far right on line 42. So I scroll down and find line 42 here. So we need to fix this that causes the vertical axis to be too far right. If it's too far right, I'm going to change this to 0, 200 to fix that error. So move on. Fix the logic error that causes the vertical axis to be drawn too short on line 48. So we go down to line 48 here. So fix the logic error that causes the vertical axis to be drawn too short there. So 100 is going to be quite short. So if I take that out and change that to 400, then that should fix that. Just scroll down, look at the next error. Fix the logic error that causes the outside square to tilt left on the vertical axis on line 56. Back to the program. Now that needs to point north, so that needs to be 90 degrees. That needs to be at 90 degrees, not 95, otherwise that won't work. Add a line to set the size of the pen to the constant big on original line 68. So we need to go down now to 68. So we need to add a line here, the turtle.pen size, and we're told it needs to be big. So it's B-I-G in caps lock. So we're nearly finished. Add a line to set the colour of the pen to gold on line 71. So here we need to add a line to set the colour of the pen to gold. So the turtle.pen colour, and that is without a U, gold, like that. Add a line to hide the turtle on original line 78. So we go down to 78, which is here. Add a line to hide the turtle. So the turtle, hide turtle. Make sure you spell it correctly. Brackets. Do not add any further functionality and do not change given lines of code. Save it as Q02 finished. So we'll save it and we'll run it. So having run the program, this is what I've got, which is what the mark scheme says I should have. Again, mark scheme is down in the description, link to my Dropbox account. So that completes question 2 for a total of 10 marks. Question 3, suggested time 20 minutes. A circle is cut out of a square of card. A program is needed to calculate the area of the excess card. The image shows the excess card in light grey. So it's cutting the circle out. You've got the area of the square, diameter of the square, 2r, and then the area of the circle, pi r squared. S is the length of the single side of the square, r is the radius of the circle, pi is the constant pi. The table shows accurate test results for 2 sets of inputs. The program has these requirements. The length of the square's side is an integer, radius of the circle is an integer. The user inputs both the length of the side and the radius, no validation required. The The diameter of the circle must be the same size or smaller than the side of the square. The variable supplied in the code must be used. Open q03.py. Amend the code to meet the requirements. So here is q03.py, and the first thing we need to look at there is we need to import math, like that. So we need to use math. So you've got your global variables there listed. We've got something to do here. Set the variable for a value of the correct data type for the area of the circle. Circle area equals 0.0. This needs to be a real, which is why we set it to 0.0. Okay, so there's some more things to do here. Main program. So you've got your side and radius input as integers. Add a line to calculate the diameter of the circle. So diameter is equal to 2 times radius. I'm just going to add a space in there. Complete the selection statement to check that the circle will fit inside the square. So if here, we need something in here to check. So if the diameter is greater than the side, then it obviously isn't going to fit. If the diameter of the circle is greater than the side, then that's going to go over the edge of the side of the square and not going to fit. So that's an invalid input. Else, add a line to calculate the area of the outside square. So we need to press tab, we need to indent. So square area equals side times side. That gives me the area of the outside square, side times side. Next one, add a line to calculate the area of the circle using exponentiation, i.e. raising a number to a power. So let's go and do that now. So circle area equals, and this is where we use our math. So we need pi, math.pi. This gives us pi, an accurate representation of pi, multiplied by radius. To give us the square, we use star star 2. So that gives us it to the power of 2. If I want it to the power of 3, I could put star star 3. That gives us a square there. Add a line to calculate the area of excess card. Excess area, again using the variables that are listed at the top, spelling them correctly and using the camel case there, the capital A. Excess area equals square area minus circle area. So that's that. So we will save that and run it. So I tried that out. Enter length of a side for the square 4. Enter the radius of the circle 2. And the excess area. Let's try with the invalid input. We'll run it again. So now we'll enter 4 and we'll enter the radius of the circle 8. And now we've got invalid input. So checking it for different things there. So that is the finished program for Q03. Save as Q03 finished, and that is 10 marks. Question 4. Suggested time 20 minutes. A program converts a binary pattern to a positive denary integer. So this doesn't deal with negative numbers. The user enters the binary pattern. The program loops continually until the user inputs an empty pattern to stop the program. A multiplier doubles for each position from right to left to generate the place values for a binary pattern, i.e. 128, 64, 32, 16, 8, 4, 2 and 1. When a 1 appears in the pattern, the place value is added to the running total. When a 0 appears in the pattern, nothing is added to the running total. The table shows accurate test results for 3 inputs. So you've got 1, 1, 0, 0 there, which is 12. Which is correct. 8 plus 4 is 12, and then 1, 0, 1, 0, 1, 0, 1, 0, 170. So that would add up to 170, and then empty, exit the program. Lines of codes in the program are mixed up. Indentation is done for you. Open Q04. So let's go and have a look at that now. So we've got to make the program work properly. You will need to rearrange the lines, so that should be interesting. So here is our Q04, and it looks very interesting. We've got our def binary loop there, p binary, which is the parameter being passed into that p binary from the main program, and it's quite interesting. It's all completely mixed up. So we can see anything that gives us a clue as where things should be going is the indentation perhaps. So we can see there for loop there, and then total equals 0. So perhaps these need to be, we assigning a variable called total, we're assigning that 0. So I think that should be at the top. So we'll start with this, and we'll start in here and start our work here. So first thing I'm going to do is take that out, and I'm going to paste that in there. So I can also see value equals 0. So I'm also going to take that, and digit equals string. So I'm going to cut these as well and paste them in here. Make sure I get the indentation correct. I'm just going to paste that in like that and then worry about the indentation later. I'm just going to take that out and maybe just press the space bar if my tab key isn't working. I'm going to take this one out as well. So cut and paste that. Well, indentation worked there. It didn't seem to be a problem with that. And now multiplier, well, let's take that out there because that's another variable. So we'll cut and paste that. And that goes in there. Okay. So now I think we're dealing with the for loop. So we'll take that out. Kind of like a big jigsaw puzzle, this. Oh, I missed off the colon there. That's going to give me grief later, so I must make sure I put that in. I think I'll just put that in manually there and just take that out. If I don't have that in, that's going to cause me some problems. So this is where we need to do some thinking. So for index in range length p binary -1, -1, -1 there, what do we need to put in next? So I'm interested in this line here, digit equals p binary index. So I'm going to cut that, try again, and paste that in here. So digit equals p binary index. So we've got our p binary there. So that's been passed in. That's the first thing I'm going to work on. So I don't need to do total just yet, but I've got this value equals multiplier times int digit here. That's going to come in next. So I'm going to paste that in there. So what that's going to be doing is it's giving me the value which is equal to multiplier times int digit. Now multiplier starts at 1, and if we look at this line of code here, we just take that and we paste that in, and then we get the indentation right. Now to do that manually, so what multiplier is, it starts at 1 and it gets multiplied by 2. So 1 times 2, 2, and it gets multiplied by 2 again, 4, and multiplied by 2 again, 8, and all the way up to 128. So that is multiplied by the int digit. And if I've got 1 there, then I'm going to add that to my total. Now I've got my total equals total plus value. So this value is being calculated there. And a multiplier equals multiplier times 2. So what that's doing is increasing the multiplier. So 1, 2, 4, 8, 16 all the way through. And value is keeping track of the value there. And then it loops around. So what that's going to do is loop around. Let's tidy that up a bit. And return that total. Let's go and have a look at this main program, which is completely mixed up. Anything to give us any clues about where things should be is the indentation. So we've got a while loop there. So what we'll do is we'll take that out, and I'm going to put that in there, and then binary equals input. So I think guessing that's going to come first, because the first thing we need is an input. Enter a binary pattern empty to exit. So while binary is not equal to empty, so these aren't in the correct order. So denary equals binary loop binary. That's going to call this function here, and then we're going to print that off. So I'm going to take that out. That's going to come first. Again, indentation is playing up for me, so I do it manually. Make sure you get that correct. So this one here is if they haven't entered correct binary number. So I'm going to take that out and put that in underneath there. And we'll get rid of these spaces here. So we'll save it as Q04 and actually look at finished and actually look at it working. So I ran that, and the first thing I got was 12. So I get, because of the loop there, because of this line here, I get to loop again. So what happens is now we input our binary number 10101010, run it, and we get 170. So if I just exit out of that, let's look at how the code works, what's happening. So the user inputs a binary pattern, empty to exit. While binary pattern is not equal to empty, then we call our function here, binary loop. So into the binary loop is passed our binary pattern, p-binary. That's our parameter. So the argument will be the actual binary pattern there, 10101010, something like that. So total is set to 0, digit is set to string, value is set to 0, multiplier to 1. So multiplier is 1, 2, 4, 8. That's going to increase every time. So for index in range, length of p binary, minus 1. So I'll be honest here, I'm not sure why we've got minus 1, minus 1, minus 1. If you know, can you let me know in the comments why that has 3, negative 1, negative 1, negative 1, not just 1, negative 1? If you know, can you let me know in the comments? But that's not what this program's about. We're not questioning that. That's not part of our question. We're just trying to get it to work. But I understand that it's looking at the length of p binary. So from index, so for the whole of p binary, for the whole of the binary number that's been input, digit equals p binary index, that's the digit I'm looking at. Value equals multiplier times int digit. So the value that I'm looking at there. So if I've got 1 in place value 2, for example, then we're adding that. So total equals total plus value. So we're adding that to our total, so 2. So 1 times 2 is 2, for example, if there was 1 in there. If it was 0 times 2, it would be 0. So if it's 1 times 2, it's 2, then we're adding that to our total there. So in the case of 170, it's 2 plus 8 plus 32 plus 128 to give us 170. So that's the finished program for question 4. Quite an interesting, very interesting question there, asking us to rearrange the code. And really the only clues we had were kind of in the indentation, which was done correctly. So that gave us some clue as to the way it worked. But please let me know in the comments what your thoughts are on this program. It'd be interesting to see why that has that for loop in there for index in range. Please let me know your thoughts on that. And that completes Q04 for a total of 15 marks. Question 5, suggested time 20 minutes. Again, I'm a real big fan of that. I think that's something you don't see in the IGCSE. And I'd really try and stick to these time frames if I were you. If you're getting to the point where you're not finishing that in 20 minutes, then perhaps you need to stop and cut your losses and move on. But anyway, question 5. A program uses a one-dimensional data structure to record the number of kilograms of coffee used each day by the local cafe. The data needs to be saved to a file. Each line of the file represents 1 week's worth of coffee consumption. So open Q05, write a program to meet these requirements. Create a comma-separated value text file named Q05 underscore output.txt. Write lines to the file, each holding 7 weights. Process all the weights in the data structure. Here is the expected output file. So we'll go and have a look at Q05. This is what you get. This is Q05 here. Here's the weights used, and we write our code here. So here's where we're going to write our code, and we've got our main program, open the output file. Let's do that first. So we'll call it the file equals open. Now, it's quite specific what it wants to be called, and that is Q05 underscore output.txt. So that is assigned to a variable called output file, a handle called output file. So that's what we're going to open. Caps lock on, output underscore file, comma, and we want W for write, as we're going to create the file, we're going to write to the file, we're going to create it. So we're not going to add to an existing file because it doesn't already exist. We're going to write to the file, we're going to create the file. So that's the first thing we're going to do. I'm going to write that file. And what I'm going to do now, what you should do straight away is save the program as Q05 finished. I'd recommend that you save the file early on for these bigger questions, 5 and 6, and that you test it regularly because you get marks for what you can do. So every time you get something right, a bullet point right, you're going to get marks for that. So we're going to meet these requirements. Create a comma separated file. Okay, write lines to the file, each holding 7 weights. Process all the weights in the data structure. So it's going to look like this: 1, 2, 3, 4, 5, 6, 7. The 7 weights per line. So we're going to need a count, and we'll set that up now. Count equals 1. So process each item in the data structure. So a for loop to loop through each item for num in weights used colon. Now I need to create a variable up here. A variable is called outline. So I'm going to use that down here. So outline equals outline and string number. So what we're going to create now is a mechanism for checking that we have 7 in each line and creating a new line. So if count is equal max per line, don't forget the underscores. So if the count is at max per line, then outline equals outline concatenated with a new line. And this now, the file dot write outline. So this is going to add that line to the file now, and set outline to be empty again, and add 1 and set count to 1. So that's if we've reached the max. But if we haven't reached the max, like 7 per line, outline equals outline plus comma. So that's a comma separated values, and then increment the count by 1. So now close the output file. So we'll go through this now and look at what we've got. So we've got the constant there used as a file name to open. A loop to process each item in the given data structure. Mechanism for controlling 7 items, that's here. Constant used to compare against count for column control. That's here on line 33. Line feed added to each line of output, that's here. Comma added to each output item except the last of each line, that's here. We're adding the comma here. File closed before exiting the program, that's really important. You must close the file at the bottom, otherwise the code won't work. So it won't actually create the file, it won't be in the folder. So what this will do, we'll run it in a minute and I'll show you it create the file, it will actually be in the folder. Okay, so we'll save it again and we'll run it. Just run in real time. So you can see I've run it there and nothing appears to have happened. Okay, so I'll close that. I'll go back to Finder, and here's what you're looking for, Q05 output.txt. That's what you need to open up. That shows that the program has actually worked there. So that is the actual file there that you need. So this is what we're looking for here, Q05 output.txt. So my program has actually worked. So when you run it, what you should find is a text file being outputted. The program looks like it's actually done nothing, but it hasn't. It has done something. It's created this text file here, which wasn't in my folder before. Now you can see 1, 2, 3, 4, 5, 6, 7 numbers per line, which is exactly what we want, which looks like the output here. So we compare it with this to end in 437, 449, 363 right at the bottom there. Yeah, that's exactly what I want. So that is the finished code there. Do not add any other functionality, no. Use comments, white space, indentation to make the program easy to read and understand. As for comments, it's already got enough comments in there. You can add, you do get a mark for adding comments. If you want to add comments into your code, you can do. That is totally up to you. Just going back into that program, just to have a look. There are plenty of opportunities for us to add comments in there. You can do, that's an extra mark. But if you're under time pressure for this, if you've just about managed to get that to work, then you probably won't be able to do that. At the very least, you should make use of white space and indentation. What that means is lines between the code and the indentation is correct. If you're using Python properly, if you're using idle, you do a colon after, for example, the loop, it should indent automatically. So that completes question 5 for a total of 15 marks. Question 6. Suggested time 30 minutes. In a board game, users build words from letter tiles. Each letter tile has a points value. There are 107 valid 2-letter words. A program is required to check each 2-letter word placed on the board is valid. Each valid 2-letter word with its points value is stored as a record in the 2-dimensional list word table. The records are stored in alphabetical order. So write a program to meet these requirements. Inputs prompts for and accepts 2-letter words from the user, AA to ZZ inclusive. Accepts upper and lowercase no other validation. Create a linear search to locate the word in word table. Stop the search when the word is located. The expected location of the user's word is passed. The end of the list is reached after all the words have been checked. Ensure that the search works for any length of word table. And then outputs. When the user's word is located, inform the user of the word and the number of points it scores. When the expected location of the user's word is passed, suggest the next word and the number of points it scores. When the end of the list is reached, after all the words have been checked, suggest the last word in the list and the number of points it scores. So, you can add comments on white space. So, I'm going to run the program now and just show you what it should do. So, enter 2 letters. Okay, so just try TT. TT is not on the list. Use UH worth 5 points. Okay, run the code again. Let's try out different combination. Let's try ZA. ZA is worth 11 points. So that's what we should be getting as our output. So this is our finished program. We'll go ahead and create it now. So here's what you get as Q06. You get the word table there, AA through to ZA, and their corresponding values there. So we'll start off by saving it. First thing we'll do is we'll save it as Q06 finished. So caps lock on, save, there, we're ready to go now. So write our code here. So we're going to create some variables now to store some values. So my word, so that's the word that the user inputs, and that's a string. We need an index, we set that to 0. Bound, we set to false at the start because we haven't found anything yet. Passed equals false, and suggest square brackets. So now we can go ahead and write our main program. So as we go through, you should comment the code. You get extra marks for that, commenting the code. So allow half an hour for that. Some of the time should be allowed to add comments to the code. This is only 2 hours this exam, so make sure you account for that. So first comment. As I go through, I'm going to add appropriate comments, but you can add more. So first thing I'm going to do is take a 2-letter string from the user. So this is the first thing I'm going to do. My word is input, enter any 2 letters. So I prompt the user to enter their 2 letters. Now we're going to convert that to uppercase because that's another one of the requirements that we need to do. So convert that into uppercase. So it's definitely worth, it is more marks for commenting the code. It is definitely worth doing if you have the time for it. If you don't, I'd rather concentrate on getting the program to work. So using .upper, we can convert whatever they put in as a string to uppercase. So now what we're going to have is another comment to say that I'm going to have a linear search stopping when found or passed over, so we didn't find it. So while loop. So while index is less than length of word table and not found and not passed, so while we haven't found it and we haven't got to the end of it, if word table index 0 is equal to my word found equals true. Elif word table index 0 greater than my word colon passed equals true. We've now passed it and we need to provide a suggestion. Suggest equals word table index, so provide a suggestion. And now our else. Index equals index plus 1. Increment the index by 1. So now, if found, so found equals true. We've now found our word. So put a comment in there that says we found our word. Maybe space that out a bit, space this out a bit. Again, I've added a line of white space there just for readability. Should always be thinking about that. So an output now, my word concatenated with is worth concatenated with string word table index, and that should be square bracket there, and this should be 1, so to give the number, and points. And what if we passed? So what's the condition if we did pass? Print, we need to tell them it's not in the list. My word concatenated with is not in the list, unfortunately. Now a suggestion, print, use and suggest, give a suggestion, 0 and worth and string suggest the points, close brackets. So again, I'm going to space this out. White space is really important. So now I'm going to deal with the else. So target is greater than the last word in the list, so suggest last word. This is the final condition, so suggest equals word table len word table. So we're getting our suggestion of word. So now we're going to print that off. My word and is not in the list. So tell them it's not in the list. Now we're going to give them a suggestion. Why not use a suggested word and worth? I want a space in there, really important, and string. So this is suggest how many points it's worth, points. So we'll save that and run it. Why it's always worth running code, I've got a syntax error, I'm missing a bracket there. So run it again. So if you hadn't run the code, you wouldn't have picked up on that and the code wouldn't work at all. So enter 2 letters, and let's use UH instead, which is worth 5 points. Okay, let's run it with ZA, worth 11 points. So that is the finished code. So key takeaways there, white space and commenting the code. So what that's doing, we'll go through the code now. Convert string to uppercase to match data given and data structure. That's 1 mark. We've got that in there. Convert it to uppercase. Linear search uses length of list for upper boundary of loop. Yep, we've got that there. We've got our linear search in here. Mechanisms to identify when item is found in the list. Yes, we've got that here. Mechanisms to identify when item is passed over in search. Yep, we've got that there. A method for tracking the suggested word is used. Yes. Use of two-dimensional indexing. Yes, we've got that here. So we've got the word and the actual value of the word for two-dimensional arrays there. Solution design, good programming practices. So that is your comments and your use white space functionality. So we've got some test data that we need to run. So we'll run through that now. So NO, it should say NO is worth 2 points. Yep, it does. Good. Okay. AA. So it should say AA is worth 2 points. Yes, it does. Okay. Run again. This time with ZA. Should say that's 11 points, and it does. Now we'll run it again with MU, and it should say that is worth 4 points. Yes, it does. Good. Run it again. This time with NZ. NZ is not on the list. Use OD, worth 3 points. Good. That passes that test. And the final test I'm going to do to check it works properly is ZH. Should say it's not in the list and suggest use ZA, worth 11 points. It does. So that passes that test, and that is a completed code there. Again, everything is linked down in the description. That's a total of 15 marks. Total for paper is 75 marks. Everything you need for this, including the files, is linked down in the description. And all of this here, I'll link down in the description, link to my Dropbox. So, a big thank you for watching. Please comment in the code how you get on with this. Good luck with your exams. Take your time, but stick to the suggested time. Thanks very much again for watching. Please like and subscribe, and I'll see you in the next video. Bye bye.